Hey everyone, Jared here. Today we're going to talk about how humanity is crafting its own killers and how, if we don't do something and do something fast, we're going to be in a very large amount of trouble in a very short period of time. Now, that might have sparked images of nuclear bombs or a robot uprising, but we need to think smaller, much smaller. Well, how small? The real threat can be distilled down to the size of just one cell. Now, to give you some context, there are an estimated 37 trillion cells in the human body, but they are no match for this threat, our tiny unicellular friends, bacteria. Bacteria are on everything you touch. You are being constantly exposed to and bombarded with these creatures. Some have even taken a liking to the human digestive tract, where they help you and me digest our latest meals. In many ways, bacteria are our best friends. We couldn't live without them. But what if I told you there was a darker side to these cells? Some bacteria are what scientists call pathogenic. They cause diseases that can lead to some pretty nasty complications, including death. Ever had food poisoning from that one sushi place down the road? Pneumonia or strep throat? You have bacteria to blame. Those nasty microbes work their way into your system and begin to replicate themselves. A lot. 1 to 2, 2 to 4, 4 to 8, up until your body is overwhelmed with invading bacteria and begins a non-stop fight to combat the foreign threat. Bacteria was the cause of many deadly diseases and historical plagues such as the Black Death. Now, sometimes our bodies are able to deal with these infections on their own, but often we need a little extra boost in the form of antibiotics. What exactly are antibiotics, and how are they related to the crafting of our own killers? To find out, let's go do some research. Antibiotics are a type of antimicrobial drug used to treat bacterial infections. And the discovery of the first antibiotic, penicillin, in 1928 is regarded as one of the greatest developments in medicine ever. It caused a shift so dramatic that bacterial infections went from death sentences to easily curable. And medicine switched its focus to the administration of antibiotics to treat these diseases. The widespread and unmatched effectiveness of antibiotics seemed a panacea, a cure-all for many diseases. Along with vaccination, antibiotics helped to bring an end to some bacterial diseases, such as tuberculosis, in the developed world. It was, by all accounts, a wonder drug. What's the problem then? It seemed that many of the world's worries were cured along with these bacterial infections, and to an extent this was true. But in the words of Robert Frost, nothing gold can stay. Scientists began to see that bacterial colonies were not responding as well to antibiotics as time progressed. What they discovered was a mechanism of selection for bacteria which had developed a resistance to certain antibiotics. This happened because all the bacteria were being constantly bombarded with antibiotics. While most were killed in this process, some bacteria expressed resistance. They did not die off like the others. These few bacteria resisted further treatment, spread exponentially, and eventually created an entire colony of resistant bacteria that could no longer be treated with the same or similar antibiotics. The development of resistance in bacteria is due to the principle of Darwinian evolution. Developed by Charles Darwin in 1859, it explains the natural tendency of life to develop and adapt to its surroundings due to the genetic diversity of its species. No two birds, bacteria, or humans are the same. Over time, less suitable members of the species die off, and a new trait that has allowed some members of the group to survive and reproduce more dominates the genetics of the group. This group has evolved. A primary goal of life is to keep living. It's no different than your instinct to not jump off a cliff, and it's no different for bacteria. The ones who can survive when we try to kill them off with antibiotics are the ones who multiply and spread their genes until all the bacteria express complete resistance, an invulnerable and bloodthirsty resistance. We can't blame bacteria for wanting to survive, but we can blame ourselves for the excessive and inappropriate use of antibiotics that pressure them to evolve. According to the Stanford Antimicrobial Safety and Sustainability Program, on average, approximately 60% of hospitalized patients receive an antibiotic, and in an estimated 1/2 of these cases, antibiotic use is inappropriate. In addition, perhaps the largest contributor to antibiotic resistance is often the most overlooked: the food and agriculture industry. Approximately 80% of antibiotics sold in the United States are used in the food industry alone. It is common practice to feed antibiotics to animals with no indication of disease or infection, creating a Darwinian breeding ground for the survival of the fittest and most dangerous bacteria. The problem of antimicrobial resistance is escalating fast. It has reached such a level of concern that the UN has declared it a global crisis at their most recent high-level meeting in New York on September 21st, 2016, making antimicrobial resistance, along with global warming, two of humanity's most pressing concerns. The number of deaths due to antimicrobial-resistant infections is estimated to surpass the number of deaths from cancer by 2050. We need to act, and we need to act fast.
So I'm here outside Stanford's Medical Center, an example of where medical professionals and research scientists alike are working to hinder antibacterial resistance by practicing antimicrobial stewardship, prescribing fewer antibiotics when other treatments can be effective, and working to minimize antibiotic use while still providing effective treatment. While many professionals are doing their best to combat these killer bacteria, it is ultimately up to us, the patients and the consumers, to stop it. Take antibiotics only when prescribed, and take them for the entire time prescribed, regardless of how you feel. It is very easy for a few surviving bacteria to again start multiplying exponentially and overwhelm your immune system before it has time to fight back. Next time you stop at the store, it might be a good idea to pick up that antibiotic-free milk, regardless of what Peggy Sue next to you thinks about the price. As individuals, these actions may seem insignificant, but remember, every waterfall starts as a drop, then a trickle, then a stream.